welcome to GCSE Product Design, Design Influences, topic number 11, Scientific Principles. Huh? I know that sounds very technical, but it's actually simpler than you think. In terms of what you need to know, it's how have modern scientific principles and new materials influenced the design of products. So for example, the non-stick frying pan makes use of a new material, and it's called Teflon. Now, Teflon is a non-stick coating which can be applied to certain metals and ceramics. It's manufactured by a company by DuPont, and it coats the frying pan using a process called sintering, where you actually sort of bake like a powder around it. And it was actually created by accident, and you'll find that quite a few modern materials are created by accident, and then they find other uses for them. Another principle you need to be aware of when designing products is how heat is transferred, and these are the three different ways that heat can be transferred throughout the materials of a product. First of all, by conduction, which is where the heat will actually travel through the product. Secondly is by convection, in other words, when the energy is transferred by the molecules, so as they actually sort of like the steam from cooking something in a saucepan. And lastly, radiation, where sort of heat is radiated out from things like radiators and electric fires, etc. Another principle you need to be aware of is material properties, but these are just the basic sort of qualities and properties of materials. You need to know these four, which are strength, elasticity, toughness, and hardness. Strength, the official description of it, is the resistance to a squashing or a pulling force. Elasticity is a material's ability to bend and flex. Toughness is the resistance to a sharp sudden impact. Hardness is the resistance to everyday wear and tear. Okay, so strength, elasticity, toughness, and hardness. You also need to be aware of some of the principles behind levers and mechanisms. Now, there are far too many to go into, but at least a basic understanding of them is all you need for the exam. So very quickly, just want to talk to you about the idea of levers. There are three different classes of levers, and they're all to do with where the fulcrum is, the load that it's lifting, and the effort that it lifts up. So an example of a class 1 or a first class lever would be a claw hammer or a set of pliers. An example of a second class lever would be a wheelbarrow or a nutcracker. And an example of a third class lever, the human arm, or if you need a product, a pair of sugar tongs or tweezers are an example as well. And if you pause the video here, you should be able just to sort of see it's just the relationship of where the fulcrum, the load, and the effort is. It's just the positioning of them. Okay, so pause this video here and just have a quick look at that, and you'll be fine. Now, levers give us what's called a mechanical advantage. In other words, they allow you to move a large output load with a small effort, and this mechanical advantage can be calculated by dividing the load by the effort. So for example, if you've got a 500 Newton load and it only takes 100 newtons to lift it up, then you've just gained a mechanical advantage of 5. Okay, because the load's 500, the effort is 100, so you've just done 5 times the work thanks to the lever. The catch is, though, is you have to move the input further. Alright, and this trade-off is what we call the velocity ratio. And the velocity ratio is the distance moved by the effort divided by the distance moved by the load. So for example, if you were using a wheelbarrow, you could use that to lift up something quite heavy, but you'd have to raise the handle of the wheelbarrow, say 40 centimeters, to get the actual bucket part of the wheelbarrow to raise by 10 centimeters. Right, so there's always a trade-off. Now, when you combine levers together, you get linkages, and there are some examples of the more popular linkages here on this page. First of these is a reverse motion linkage. It's not animating, but you can guess what's going to happen. As you pull this one to the left, this one will move out to the right, and this mechanism is used a lot in windscreen wipers for cars. Second one is something called a parallel motion linkage, and this is the kind of linkage you find on toolboxes to make sure that the top layer sort of moves and keeps nice and level. You can see it here on this animation. The third linkage you're going to look at here is something called a bell crank. Now, bell crank is moves it around sort of 90 degrees, and you'll see this on sort of braking systems. This one's on a suspension system on a bike. You also need to be aware of pulleys and chains. Nothing too in-depth, but you at least be able to remember that pulleys are used to transmit rotary motion. Okay, so as one pulley moves round, another pulley moves round at a distance, okay, away from it, and it's connected together with a belt or perhaps a chain. In terms of the scientific principle, the size of the wheels affects the speed. So if this is your motor here that is spinning and it's got a diameter of 200, every time that spins round once, this larger wheel will spin round once as well. So this larger wheel will actually end up going, that's right, a little bit slower, okay, because it's got to turn all the way around there in the time that that one takes to turn around there, so it will actually turn slower. And the same again with chains used on bicycles. Okay, the chain is there to affect the torque, okay, so you can get a maximum amount of turning force. That's why you don't see pulley belts on bicycles, because they're not efficient enough. They would slip all the time. Speaking of bikes, you need to have a rough awareness of gears. Gears are used to transmit rotary motion again, but over shorter distances. In other words, they have to be right next to each other. Pulleys can be far apart because they use this belt to be connected. Gears have to be right next to each other. You can see an example there inside a clock. Alright, and usually the one that does all the work is called the driver. The one that actually gets turned by the driver is called the driven. Bevel gears, as you can see here, they're quite special because they change the direction of the rotary motion by 90 degrees, and you find bevel gears on hand drills. Rack and pinion turns rotary motion of the pinion here into linear motion on the rack, and this mechanism is used on corkscrews. Okay, so as you screw this in, you move this part, the pinion part here, and it moves the rack up, and that's what pulls the cork out. Cams are used to change rotary motion, okay, round and round motion, to up and down motion, and you see them in the department. We've got quite a few on a shelf up in S1, used in little children's toys, okay, and as they turn around you get different types of movement. So a typical question from 2008 for you to have a go at is this one here. Again, I say there's looking back over the years, there's very few questions to do with the scientific principles. This was about the only one I could find, which requires you to have a knowledge of the rack and pinion. The other main part again is just two properties, so don't worry too much about it. It's nothing that you have to revise massively, but it just needs to be there at the back of your head just in case a question pops up with a little requirement. Okay, thanks for listening. Don't forget to like and subscribe.